Welcome back. Let's talk about depth first search now. We've implemented our breadth first search and we feel comfortable for that. But what about depth first search? Going down our tree and exploring the deepest part of that tree before we come back up and explore the right side of the tree as well. And when it comes to depth first search, we have to be aware that there's 3 ways that we can actually implement it. It's called in order, pre-order, and post-order. Remember how we had the list that we got with breadth first search? Well, there's 3 different orders that we can return this list with depth first search. The first one is called in order. And it looks something like this. We go with 33, 101, 105. It's called in order because in a binary search tree, it gives everything in order. If we take a look at this list or this tree, ideally in a in order traversal using depth first search, we would get something like this. We would get 1, then 4, then 6, because we go 1, 4, 6, and then we go 9, and then we go all the way down to 15, and then we come back up to 20, and then to 170. It's in order because, well, look at that. Everything is in order. So this is really useful if you have a binary search tree like this. Another way that you could return it is called pre-order. And pre-order starts off from the parent node down to 33 and then down to 105. So we start off with the parent and then grab the child nodes left to right. In our case, it would look something like this. We would start off with 9 because it's the parent one. And then we grab 4 because it's the next one in the list. And then we go 1 as we're traversing all the way down. Remember, we're doing depth first search, so all the way down. And because we got to the very bottom, we now go back up and down to 6. So we see here we did 4, 1, 6. And then we go to the right side to 20. And then grab 15, then 170. And you're asking yourself, this seems kind of useless. Why would we ever want to use pre-order? I mean, in order, we had everything in order. Why would we ever need this? And pre-order is really useful if you want to, for example, recreate a tree, right? Because with pre-order, I can just go 9 is the root node. Then we have 4 as the left-hand side, 1 as the left-hand side. And then from there, we have 6 on the right, 20 to the right of 9, 15, and then 170. We can recreate a tree really easily because it's ordered for us versus the in order method that didn't have that order that we wanted if we wanted to recreate a tree. Another way, and the last way to do this, is called post order. And post order is the last option. That is going all the way down, grabbing 33 and 105, then going to the top, to the parent. So 33, 105, 101. So in our case, a post-ordered depth first search would look like 1, then 6, then 4, and then going back up all the way down to 15, then 170, then 20, and then finally 9. We search the left-hand side first, the children come before the parent, and then we search the right-hand side first, and the children come before the parent. Now, these 3 types of ordering are really specific, and although it may look confusing right now, you'll see that when we write it in code, it's not that difficult. You just need to know that when it comes to depth first search, you have these 3 types of traversals that you can do that you may want to implement depending on your needs. But the easiest way to show you how this works is, well, to actually do it and code it. So let's do that in the next video.